Hello friends, this is lesson 16 of NLP Natural Language Processing, and today's lesson we are going to cover the following topics. First we will be discussing about text visualization, then we will see Matplotlib library, frequency distribution plotting, dispersion plotting, and at last we will see yellow brick library and text visualization. Now let's start with the first topic and see what is text visualization itself. So text visualization or data visualization is a general term that describes any effort to help people understand the significance of data by placing it in a visual context. So here from this definition you can easily understand that why we are doing visualization or text visualization. The main purpose of text visualization is actually to help the people understand the significance of data. See, whenever we are getting the result after the computation or we can say modeling result, so what we have to do, we have to visualize the result. The purpose of this is actually to make the people understand the result, because people are not technical people. Few people, if they are technical, they can understand what is the logic and how the data is maybe analyzed, processed, all those things. But for non-technical people, it is so much difficult to understand. So instead of that, instead of having the data or the result in the form of text or maybe in the form of table, it is better to visualize it in the form of charts, graphs, or we can say plots. Another benefit we can say of text visualization is it is helping us to recognize the undetected patterns, trends, and correlations. If we have missed any of them here, like patterns, trends, correlations between the features, all those things, so by visualizing the text, what will happen, we can easily detect all those things. What are the patterns missing here, the trends, the correlations, it will be easily detected, these things. Presentation of results from applied text analytics is significantly less straightforward compared to numeric data. So data visualization, if it is numerical data, it is simple compared to text visualization. Here we have to find the most informative features, and the features can be words, phrases, fragments, sentences, paragraphs, all those things, right? So compared to numerical data, it is tricky, or we can say it is less straightforward. Creating visualization is easy, friends, but it is important to produce a good ones. That is difficult, or we can say harder. Visualization, creating visualization is easier but much harder to produce good ones. Now we have different types of libraries using for text visualization or data visualization. The most common one which will be used is Matplotlib library. So what is this Matplotlib? So Matplotlib is actually a 2D plotting library for data visualization. It is used to produce like line plots, graphs, charts, scatters, histograms, pie charts. For all these things we can use Matplotlib, and it is 2D plotting library. This you have to remember. It is lightweight, it is simple, that is why it is used the most. Here then we have frequency distribution plotting, and you know in previous lectures we talked about frequency distribution. Frequency distribution means how many times a specific word is repeated within a text. That means identifying the words that are most informative about the topic and genre of the text. So how many times a word or a token is repeated within a text, that is called frequency distribution. Now if you want to visualize the result of frequency distribution, so NLTK Natural Language Toolkit provides a built-in function for us, and that built-in function is for finding the frequency distribution. We can use this function, frequency distribution function, and then after that the result of that we can plot using this plot function. And here we can mention how many frequent words we want. Like here in this case I want like 50 most frequent words. You can put any number here. Like, so just by calling this plot function we can visualize the frequency distribution of the tokens or data, right? And this plot function is actually taken from matplotlib. Also we can plot the cumulative frequency just by adding an attribute here, like we say cumulative is equal to true. Here you just mention the number of frequent words, how many words you want, and then here you give the attribute like cumulative is equal to true. Then this will plot for us the cumulative frequency. Then we have another type of plotting which is called dispersion plot. What is this type of plot? This type of visualization is used to display positional information, friends. Positional informations, where each stripe represents an instance of a word and each row represents the entire text. So here it is actually displaying positional information. Like in a tokens, like in this sentence, if we consider this sentence. So using dispersion plot, and we want to see where the display is present in this sentence. So you see that display is present in the last, right? So that will be represented by a stripe like this. And for that we have a predefined function. Again here, friends, we have to use this predefined function from matplotlib, and that is dispersion underscore plot. And here you just give the number of tokens, which tokens you want to display the positional, right? But one thing you have to remember, that this text is nothing but NLTK text. It means the data should be first converted into NLTK text, then you can apply this function here. For example, this is a sentence. First of all, we want to tokenize it. It will be in this form, and then I want to see the positional of this one, how many times it is repeated, and also in which positional or positions it is there. So first of all, it is showing me it is there in the first position, and then it is here stripe we have the second position, right? It will be displayed like this. Then we have another library which is we can say this library is also interactive library. We can call it interactive library. It is also used for text visualization, data visualization. The data may be text or numeric data. For both we can use it. So actually this yellow brick is an open source Python project that extends scikit-learn API and wraps matplotlib to create interactive data exploration. So compared to matplotlib, it is interactive and it is like multidimensional. It is not 2D, it is 3D, or we can say multidimensional data we can represent using yellow brick, and it is interactive compared to matplotlib. It contains visual diagnostic tools for the data for the analysis and interpretation of machine learning overflows. So it has some visual diagnostic tools for this purpose. Now if it is not installed for you, how to install it? It is very simple, friends. Just you type sudo pip3, you know that this pip3, then install. You just put here yellow brick, and it will take about 1 minute or less than that. It will be installed, right? And after that you can like use different visualizations from this library. Like we have frequency distribution visualizer, we have TSNE visualizer for clustering, and then we have classification report visualizer, and we have confusion matrix. So many other visualizers we have, and we can call them and use them in our project. Now let's start see all these things practically here. For that I will open here Jupyter notebook, and first I have to execute this part because I need these libraries. Matplotlib is there, NLTK is there, and also pandas we are using. And then we talked about text visualization, and we said text visualization is a general term that describes any effort to help people understand the significance of data by placing it in a visual context, right? And then we talked about Matplotlib, and we said it is a 2D plotting library for data visualization. Now, for example, here we will be considering this text which is taken from bbc.com/news. This is a simple text. This we will consider and will tokenize it, and then we'll plot the result using different plots. For that, first of all, I have to normalize the text. For normalizing, I am using NLTK. First, I am tokenizing the text, and at the same time, I am converting it to lowercase to remove the distinction between upper and lower cases. And here, one by one, I will check here and see whether it is there in punctuation or not. If it is there in punctuation, we just ignore them. Otherwise, those tokens will be considered one by one. And here we'll see the result. First, I have to execute this part. Yeah, because here it is saying BBC News is not defined. Now, if I execute, now see friends, all are converted into lowercase, and at the same time tokenization is applied and punctuations are removed, right? Now let's see here frequency distribution. For frequency distribution, I will be using this function and give the tokens here as an argument and see the result like this. 2, the first token, it is repeated how many times? 11 times. And B is repeated 6 times, word is repeated 6 times, and like that the frequency of each and every word is represented like this. And now we want to plot that. If you want to plot and we consider only 30 frequent words, here you just execute this function, frequency distribution dot plot, and in the result you can see like this. These are the words, or we can say the tokens, and these are the frequencies or counts we can see. And you know that B was repeated how many times? It was 11 times, right? Yeah, it is 11 times. You see here, so it is 11 from here, it is starting, and then we have B, then we have word, like that. The most frequent words will be displayed, 30 words, like this. This is called the frequency distribution plotting. And at the same time, if I am adding here another attribute and say cumulative is equal to true, so this will plot for us the cumulative frequency, and this is the cumulative frequency plot. And here we have B. So B, how much it was? It was the frequency for this was 11. So 11 will be added, the frequency of that will be added to the next frequency of token, and that the same, this procedure will be repeated for all the tokens. Like here we have 11 plus the frequency of that, so the result of that will be added with the frequency of word, the result of that will be added for the frequency of that, and like that it is plotting for us, and this is called cumulative frequency. And now if we are using dispersion plotting, and you know that dispersion plotting is actually used to display, and see, first of all, what we have before, we have to first convert the text or data into NLTK text, and then we can call this function. If it is not converted to NLTK, then we cannot call this function. And here I want to see word, how many times it is repeated and in which positions. TikTok, how many times it is repeated and which positions, up and Google, right? Now let us see the result here. So you can see that the result word is the first token. It is repeated how many times? 6 times. This is the first position. And which position it is repeated? You consider this one 20, 22 or 21 maybe. Like it is in 21st position. It is the first position of that. And then it is in 60th positions. And like that it is in different positions it is displayed. And how many times it is displayed? It is 6 times. The second token is TikTok. It is repeated 2 times. App is repeated 4 times, and Google is repeated how many times? It is repeated 3 times. Now if you go back to text here and see, you will find here word, yeah, it is here. When you count the number of tokens from the beginning up to here, you will find this position maybe 22 or 21. This is the first position. Here the first position is 21st, right? And this position is about 61 or 62, like that. And then I will find the conditional frequency, and I want to use bar chart for that. And for that I'm considering names corpus. If you remember from previous lectures, we have a corpus called names, and that I'm using NL corpus. Then I'm importing names, and you know, within this names corpus we have two types of files. We have names for females and names for males, if you remember. So this is the first file and this is the second file, and within this file we have names for females, and here we have names for males. So what I am going to do, I will combine them and create a single file, right? But how to combine them? I am saying the names which are coming from this text, just assign a label, and the label is male. Any name which is coming from this male.txt, so the label for that will be male, but the name which is coming from, the label will be assigned for them female, right? The result is stored here in this variable called both names. Let me display here some of them, and you see the result like this. So they are all combined, and here we have the names, and in front of them we have the labels, or we can say the gender. Now then I find the conditional frequency here by considering the last characters of the names, right, from each file ID. Like here names ID, we have two IDs. If you remember, here we have two IDs. This is the first ID, this is the second ID. So two IDs we have here, and we'll be considering the last characters of them, and then we will plot here. It will be in this form. If you remember, in previous lectures we did talk about all these things. The names in, for that we had more number of names for females. You can see that here it is showing us that females, this color, blue color, represents females name, but these are the names of female ends with A. How many names are there? More than this number, the frequency or the counts. But if you come to here, like the names ends with N, then we have more number of males compared to females, this orange color, right? So here if you come again for S, there again we have more number of males, but if you come to Y here, then we have more number of females compared to males. This is called the conditional frequency plotting. Like this you can plot it. And now one thing else I'm going to do, I will convert it the names what I'm reading one by one from this variable names, and I created here two lists, one list for names and another list for genders, and the names will be appended to this list, and the genders will be appended called G, like this. And now here I will convert it into dictionary, and then the dictionary is converted into data frame, and this is the very easiest way you can do this. First you have to convert it into dictionary. Like here we have the label is name and the data which comes from this list, right? The second label is gender and the data comes, and that is converted into dictionary. Then I'm converting dictionary into data frame, and you can see this is the result. We have names and we have genders. Now if you want to plot them and you want to see the result in the form of bars, here I say kind of plot is equal to bar group by genders, because we have only male and female, and then you count the number of names, how many names we have for female and how many names we have for males here, and type of plot I have chosen here bar, and let us see the result. Yeah, this is the result, and this is called bar chart. We have two labels, female, and we have all the labels, and these are called the frequencies or the number of names what we have here. And you can see easily, you can compare in that file we have more number of female, number of males. And then we have Yellow Brick library, and I told you Yellow Brick library is interactive library, and it wraps Matplotlib, and it is more interactive compared to Matplotlib is a 2D library, and this one is more interactive. And you see here, let me execute here. You have to import like this yellowbrick.text.frequency. I want to plot the frequency distribution as we plot here also. Here we did plot frequency distribution like this, right? But this time I'm using Yellow Brick library, and I want to plot the frequency distribution, and for that frequency distribution here it has a visualizer, right? This you have to import frequency visualizer. And then what I have to do, I have to do feature extraction, and for that I'm using count vectorizer. This we already discussed in previous lectures, if you remember. Here I am instantiating my vectorizer, and at the same time what I am going to do, I will remove upwards, and then using my vectorizer I will convert them all into document turn matrix. And then what I am going to do, at the same time I will be consider my features. From here I will calling the named get underscore feature names, right? So here we have features names, and then by calling here this creating the function or instructor here, and passing feature names and type of or vertical, and then here you have to fit the model, or we can say the visualizer, by calling this function visualizer.fit, and this tokens which are converted into document turn matrix given here, and then you call here visualizer.poof. This function you have to call at the end. Instead of this poof function you can also use show function. Let us see the result, friends. Yeah, this is the result, and you see here frequency distribution of top 50 tokens, and you see here, and these are the tokens. If you want to visualize, like considering unsupervised machine learning, in unsupervised machine learning, if you remember, there we had something called clustering, means grouping the features based on similarity. For that we have here a visualizer called TSNE visualizer, yellowbrick.text. Then you have to import this module. The same, what you have to do, you have to instantiate, it means call the fit function, and then you call the show function at the end. Here what you have to do, you have to first of all convert the tokens into here the matrix, I mean document term matrix. You have to do this transformation, you have to do, then you just call the function, it will be displaying for you like this. Yeah, you see, friends, this is the result what we have. You see we have clusters, and these are also clusters, small clusters, these are also clusters, and some of the features which are, we can call them as a outliers, because they are so much far from the from this point, from the main point, right? It will be displayed like this. Now again I will be reading some text. If you remember this text, email the I'm using pandas, and then at the same time I will drop the null values if there is any. Let's see the result like this, and I want to plot the labels here, the messages based on labels. I will group them by labels, because only we have ham and spam, and then we have the messages. I want to count the number of messages. At the same time, kind of plot is equal to bar. You can easily see the result like this. We have two labels, spam, and then we have ham, and you know that number of hams are more than number of spams. These are called the labels, and these are called the frequencies or counts number of ham or spams. And at the same time we will be using classification report from yellow. For that what you have to do, yellowbrick.classifier, and you have to import this module. The remaining things, you know that first of all we have to transform the text into numbers, and you have to mention the type of model, which model you are using. And here for splitting the data into training and testing, we'll be using this, right? So these are my features and labels, messages and labels. What I'm going to do, first I'm going to transform them into document term matrix, it means to numbers. Then it is splitted here into two parts, training and testing, and then I'm creating my visualizer. From here you have to understand better. So we say visualizer is equal to classification report. What is the model? I say multinomial model I'm using. And then classes, what are the classes? We have two classes, we have ham and span, right? And then you have to call the same visualizer, and these are my training data, and at the same time visualizer dot score, and then we have testing data, and then here you have to call poof function or show function, and you can see the result like this. Yeah, friends, see, here we have two labels, we have span and we have ham, and this is the precision recall F1 score. So you see here we have 100% for span, the precision 96%, and here we have recall for ham, we have 100%, and for span we have 72%, and this one F score we have 98% for ham and 94%. These are two labels and these are the metrics, and whole thing is called as classification report, and this classification report is generated by yellow brick library here. If compared to like matplotlib, if you draw that, if you want to display confusion matrix, for that also we have a visualizer. You have to use yellow brick dot classifier, and you have to import this module. The same way you have to use and instantiate it first. What is the model, the classes, and then you have fit in score. Here we have training data, and here we have testing data, and at last you have to call show function or poof function, and you can see the result like this. Yeah, friends, so we have here two types of values, predicted values and actual values. So these are called actual values or true values or true class, and here we have predicted class. Here we have ham and spam, here also we have ham and spam, and here you can see this one is true negative and this one is true positive. I have already discussed these things lectures. For better understanding, you can refer my data science lectures also. I have already talked about confusion matrix, what is true negative, true positive, true false positive, false negatives, and how can we calculate the accuracy, how to calculate the precision. But here I am not discussing all those things. Here we have two labels, ham and spam, and here also we have ham and spam, and these negative, true positive, false positive, false negative. These are nothing but two types of errors, type 1 and type 2. So actually we wanted to visualize here confusion matrix, and this is the way how to visualize it. I hope you understood all these things, friends, different types of visualizations, and it is important as we discussed here because visualization is actually the effort to help people understand the data by placing it in a visual context, especially for non-technical people it is important. So these were the topics which we promised. I hope you understood all these things. Thank you.